Question 2 asks you to simplify this expression. This is goal topic 10A in our course, which is to simplify an expression involving fractional exponents and using the the properties of exponents to do so. So what would be your instinct? Where would we start simplifying an expression that looks like this one?
I'd go back to module 1.
Okay.
Adding
And do what?
or subtracting the fraction by finding the least common denominator.
That is an excellent idea. After all, we're going to have to do arithmetic with these exponents because we know that if the shoe were on the other foot, even if we had whole numbers as exponents, let's say I had y to the third divided by y to the fourth times y to the minus 2. This is not the same problem, but if we just compare what we would do in that problem, we would end up needing to do arithmetic with the exponents, maybe adding them, maybe subtracting them, maybe multiplying them, whatever, maybe dividing them. And if we have to do that same arithmetic with fractions, we're going to have to pull out our understanding of how to do arithmetic with fractions that we had from the beginning of the course.
For the sake of knowing, you would multiply the exponents, right?
Would you? So that's going to be my next question. What operation do we want to do first on the exponents that are here? Let's, for the moment, think about the example with whole numbers instead of the one that was given. What would we want to simplify first in the expression y to the third over y to the fourth, y to the minus 2? We could choose to move the negative exponent to make it positive, or we can choose to do that at the end. That's up to you. I usually prefer to wait until after we've done all the arithmetic.
Least common denominator?
Well, is the least common denominator appropriate in this example with whole numbers? We'll think about that when we need to, but for now I want to make sure that the overall strategy is clear.
Just put y over 1 over y to 2?
So that was also John's suggestion. Okay, let's do that since it's come up a couple of times. Let's take the y to the minus 2, and to make its exponent positive instead of negative, what do you want to do with it?
You want to flip it? You want to
Yeah,
flip over 1 and flip it?
right. We want to make it
Don't
1
flip
over.
the entire thing, you just
That's right, just that factor. Y to the minus 2 in the denominator is the same as y to the positive 2 in the numerator. And then our y to the third stays there. Our y to the fourth downstairs also stays there. And now we don't have to worry about negative exponents, at least at this point. We've made our negative exponent into a positive. All right, what happens next?
You want a factor here?
In what way?
You've got to find out which is the most common factor amongst them, which would probably be 2.
Well, that would make sense if we had a bunch of terms added together. I would want to factor the numerator using its greatest common factor and then try to cancel what we could cancel. The issue is here that we only have one term really in the numerator. That term is y to the third times y squared. So add what?
3 and 2.
Yeah. And how do we know to add exponents here? Because we're multiplying powers of the same base.
Now, if it were involving parentheses.
Yeah. Yes, if we were taking a power of a power, we would multiply the exponents by one another. But because we were multiplying powers, the exponents got added. So upstairs we have y to the fifth. Downstairs we have y to the fourth. How do we finish simplifying that?
Take,
Y to the 4th. It'll be y to 4.
actually, take 4 away from the bottom.
Yes.
You have a remainder of y. Or y to the first, or
Yeah.
just y.
Yeah, exactly. Well, you're both right. You can look at it either as we factor y to the fourth out of the top, y to the fifth, and then cancel it. Or, equivalently, because we're dividing powers of y, that's the same as subtracting, taking away the exponent that's on the bottom from the one that's on the top. Y to the 5 minus 4, otherwise known as y to the 1, otherwise known as y. Yeah. And that's all there is to it. So that's the overall strategy for how we would approach this problem if the exponents were all whole numbers, right? We would turn the negative exponent into positive. Because we're multiplying powers, we would add exponents. And then because we're dividing powers, we would subtract exponents. And then we'd be done. So if we apply that same strategy to the actual original problem, what does that look like? Well, what do we want to do first?
Put the 1/2 up on top and make it whole.
Yeah, let's do it. If we're following the same strategy, let's just take that negative exponent, bring that factor up top, and when I bring it up top, it becomes y to the 1/2. And I still on top have y to the 1/3, and I still on the bottom have y to the 1/4. Okay, so now all our exponents are positive. What happens next? Add up what?
You add up the 1/3 and the 1/2.
Yep, because we were multiplying those powers, that's equivalent to adding the exponents. And now is when we plug in our memory of how to add fractions. What is 1/3 plus 1/2? How do we do it?
Common denominator.
And that is 6, right? So using the least common denominator of 6, what are the numerators going to be? 2 and so when I add 2/6 and 3/6, I get 5/6. So in the numerator we have y to the power 5/6. In the denominator we have y to the power 1/4.
Makes a lot of sense.
How do we finish? What's the last step?
Subtract them.
Subtract them. And so now we have another fraction arithmetic problem, 5/6 minus 1/4. What's a common denominator for them?
No.
Yeah, we could use 12. 12 is the least common denominator that we could use. We could also have just multiplied them and got 24 at the cost of having to do some additional reducing at the end. How many twelfths is 5/6? 10, because we multiplied by 2 in the denominators. How many twelfths is 1/4? How many twelfths is 1/4 equivalent to? Well, but I multiplied this 4 here by
Oh,
3.
Oops.
Yeah.
Yeah, 3.
And 10 twelfths minus 3 twelfths?
7/12.
7 twelfths. And so, as the British say, Robert's your mother's brother. We're done. Bob's your uncle. Yeah.
Never heard it said like that.
Yeah, I know. It's when British people feel like being even fancier. They'll say Robert's your mother's brother.